we have graphed square root of x, half a sideways parabola. You can go ahead and try it on your calculator. So it starts at the origin and goes up and to the right, that half of the parabola. If you graph on your calculator, y equals square root of negative x and y equals negative square root of x, they do different things. This one doesn't flip it upside down, it flips it backwards. So that's interesting. We're used to seeing the negative, like for instance, negative x squared does flip things upside down. So notice that where it used to be like this, flipping it upside down makes you the bottom half of the sideways parabola. In words, let's just write it down. Square root of negative x backwards. Technically, we like to say it moves points horizontally across the y-axis. So if you had a point over here, it gets flipped back across the y-axis, horizontally moved to the new point here on the curve. Similarly, a negative in front flips you upside down, and I'm okay with writing upside down instead of reflect across the y-axis, but let's just write it down formally.
Ooh, x-axis. Sorry. Hold on, let me make that x-axis. That's bothering me. X-axis. Okay, fine. That's an x.
As you get more comfortable with this, you might want to think about why this happens. Imagine a point like 9 for x. Y would, for square root of 9, y would be 3. Negative square root of 9 would be 3 down instead of 3 up. Okay, if we graph negative root x plus 2, we have two combinations outside. When I say outside, I'm looking at the parent function as being whatever's inside the square root sign in this case. If the parent function was absolute value of x, then inside would mean inside the getting absolute valued. Okay, if you graph this one on the calculator, you see from looking at it that it is up and then flipped upside down. So the normal order of operations is what? Flip upside down first, because you're multiplying first. So and then move it up too. So what do I mean by that? Well, let's take a look at what happens if we are deliberately trying to do the order of operations backwards. If I have to do that with parentheses, of course, because parentheses override everything. Square root of x plus 2 is the regular square root.
Yeah, you go up 2.
See the very first graph. And then up 2. If I then reflect it, notice that the positive 2 moves down to negative 2. And and you reflect upside down, it no longer looks like it has gone up 2. It now looks like looks like you have subtracted 2 instead of adding 2. And notice if I distributed, I actually, without the extra parentheses, I would have the same as negative root x and then down 2 afterwards. So I point this out because horizontally everything is backwards, including the order of operations, which is really unfortunate, but that's because there's no equal sign between the x and what you're doing. So for example, if I graph the negative square root of x plus 2, what I'm graphing is square root of x plus 2, which is left 2. So again, it's the regular function, square root function. Let me just draw that with dots and blue again. Regular square root function shifted left 2. Okay. And then what happens? Then I reflect afterwards. The easy way to remember it is whatever's closest to x for horizontal stuff, whatever's closest to x is last. So I reflect this one afterwards, and the negative 2 flips across to a positive 2 as. So you have to be careful with this. This is reflect last, switches where the thing starts. So. Okay, so we'll practice a few of those in the homework, and I just wanted to make sure that you realize that everything horizontal is backwards, and horizontal is anything inside the parent function, so inside the square root sign in this case.